Hi good people, Titus here for part 3 of the grid system tutorial, and in this video we'll set up the movement code for our player to move between the tiles. Let's not waste any time and jump right into it. Alright, so we're going to open up our BP_grid, and in the last one we created the last of our private functions. This time we're actually going to create some public functions to actually facilitate some of the movement here. We're also going to need a macro, and I think we'll create that first because that's going to be the easiest. So we'll hit the plus sign under macro, and we'll just call it tile check. Under the inputs here, we're going to need 3 input pins. So we'll hit the plus sign. The first one we'll call execute, and we'll set that to be the execute color. We'll hit the plus sign, and then the next one will be the row, and we'll set that to be an integer. And then the last one we will call column, and then that one will also be an integer. Now for the output, we're going to need about 4 pins. The first one is going to be titled then, and will be set as an execution pin. And then the second one we'll pass in will be a valid, and that's going to be a Boolean type. And then the third one is going to be return row, and that'll be an integer. And then the last one we'll call return column, and that will also be an integer. Now the code on here is going to be pretty simple. We'll go ahead and hook up the execution pin, and then what we can do is we can pull off the row first, and then we'll come into a greater or equal check. And then we're going to check if it's greater than or equal to 0, and then we're going to pull that into an AND Boolean. We're going to be doing 4 different checks, so we can hit this plus pin to add 4 pins here. So we got, is the row greater than or equal to 0? We also need to check if the row is less than the number of actual rows in our grid. And then we'll hook that up to the second pin here. Now we can pull off the column pin, and we're going to check if the columns is greater than or equal to 0, and we'll plug that in here. And then we'll pull off the columns one more time, and we'll check if it's less than the number of actual columns. And then maybe I'll sort this like this. And then don't forget to hook up your Boolean checks here. So if all 4 of these pass, we will pass the valid check here. And then we also want to return the rows and the columns, so we'll have access to those from any function or area that happens to be calling this macro. So we can just pass these in like so. And this will complete our macro. Alright, so we're going to go to the functions and hit the plus sign. And this function is going to be the tile location. We're going to define this as a public, and we'll create a new category called public. And this just helps keep it organized here. So now we have a private and public set of functions. And the tile location is going to take in a singular input. The input's going to be called the mouse location, and it's going to be a vector. So basically this function is going to take in the value of where our mouse clicks, or where the mouse location is, and then from it, it'll do some math and pass back basically the row and column and whether or not it's valid. So for our outputs, we're going to hit the plus sign, and the first output will be a valid check. That's going to be a Boolean. Second output will be a row, and that's going to be an integer. And last output will be a column, and that will also be an integer. Now we pull off the execution pin, what we can do is do our tile check macro, and then our macro can pass in the valid, the return row, and the return column for us. And then we can do all the math and pass the information into the tile check here. The first thing we'll need is this mouse location, so we can right click and say get mouse location. And if you weren't aware, you can use these pins, you can pull off it and do the checks, or you can do a get on the same variable. So these are effectively the same. And then sometimes it's easier just to do it separate, just so the code looks a little bit cleaner. And we can right click and split the structure pin. We're going to be doing 2 calculations, so we're going to need to duplicate this with Control D. In the first calculation, we're going to be using the X value, and we're going to subtract that against the actor's location. So we can do get actor location, split the structure pin, pass in the X value here. So basically we're getting the mouse location and we're subtracting this against the grid location. So that would be this point in this corner right here. And then with the second calculation, we're going to be doing this off the Y value. So we'll pull off the Y and do subtract. And then this is going to be the same, get actor location. We can split the structure pin, but instead of the X value, we'll be using the Y value. Now from these results, we can pull off into a divide node. And we can do that with both of these. And then on the X value, we need to use the function we created in an earlier video where we defined the line width. So we can right click and actually call into line width. And then we could pass that value in here. For the bottom calculation, we actually need to use the function we made called line height. And then we'll pass this value in here. Now we can use this result and we can actually call it into a multiply node. So if we run a search for multiply, and you may want to do it separate. The reason I say do it that way is because we're going to be using the rows for the X. You'll notice if we plug in the rows, this turns this to an integer, and this needs to be a float value. So if we plug this in here, that should convert to a float. You notice it didn't. You can of course right click and manually convert it to a float, but another way you can do it is just disconnect the pins, and then if you connect your float in first, it'll make the conversion from int to float, and then this actually will maintain the way it needs to be. And then we're going to do the same thing over here, but this time instead of rows, we're going to use columns. So I'm going to right click and just get a multiply node. And I'll plug the float value in first. And I'll plug the integer value in second. And now this is green instead of, I guess, teal. We can pull into a floor node just to round the value down. And our X value is going to go into our row, and our Y value is going to go into our column. And this pretty much completes the code for the tile location function. So that's the first of 3 public functions that we're going to need to be able to do this math. So the second public function we'll need is going to be our grid location. So we'll hit the plus sign, call it grid location, and I'm going to move it in the public category. And the grid location is going to have 3 different inputs. So we'll hit the plus sign under input. First one's going to be a center question mark, and that's going to be a Boolean. The second input will be a row, and that'll be an integer. And the last input will be a column, which will also be an integer. The output pins, there's going to be 2. One will be a valid check, which will be a Boolean. And then the last output pin will actually be a grid location. And we could set that to be a vector 2D. Alright, and that has our preset up here. We can pull off our execution pin into our tile check macro again. We don't know offhand what's going to call this function. It won't always be called from the tile location, so we may need to check to see if it's a valid tile. That's why it's good to have the macro ready. So we can pass in our row and our column, and then we can begin to do some of our math. Now we can pass the valid check into the return node. That way whatever calls this function will have access to know whether it was a valid grid location or not, so that can sometimes be handy. So I'm going to pull the return row into a multiply node, and then we can use the tile size, and then off that result we can pull into an add pin. And then similar to what we did in the previous function, we can do get actor location, which is a reference to the grid. And we can right click and split this structure pin, and we can use the X value into this addition. And then we'll pull into a final add node. And then what we're going to be adding together is basically going to be the tile size. So we can copy paste this over here with Control V. Pull into a divide node, and we can cut it in half. And what we need is a way to give one of two possible values, because when we're using this function, we're going to basically calculate either the center of the square of a grid, or we need the edge of a grid. The way we can do that is with a select node, but if you right click and search for select, it'll give you this one, which is not the one we need. It's easier if you use the Boolean check, which is the center question mark. So we can just right click, get center question mark. So this is the same as this Boolean here. And then we can use this and pull off of it into a select node. And this will actually give you the one that you want. So if center is true, then we should take the tile size and divide it by half and use that result. If it's false, we're going to use 0, which is going to be the bottom left corner of the tile. That gives us both options here, depending on what we're doing. We're either going to be using this to highlight the tile, or we're going to be using this to move the player character to the center of the tile. So that's why you need an option to either get the center or you want to get the bottom left corner. Because depending on what you're doing, you're either highlighting the tile or you're moving the character to it. In all likelihood, you're doing both. Now this is a vector return node, so we can right click and split it. That way we can pass in the X value because we did this on the row, which is our X. So now we need to duplicate this. So we can press Control C, Control V. And then we will return the column into this check here. It's going to do the same math. It'll use the tile size, multiply that against the column, and then it'll add that against the grid's actor location, but we don't need to use the X value. We need to use the Y. We're then going to add that to either 0 if we're not using the center, or if we're using the center, we need to take the tile size, divide it by half, and then add it to that. And then we can pass this into the Y value. And this pretty much completes the grid location function, which is our second public function. So the last public function we need is going to be our select tile. So we can hit the plus sign here. We'll call it select tile. And we will move this into the public category. Now this function is only going to have 2 inputs and it won't have any outputs. So we get the plus sign and we'll simply use a row, set it to be an integer, and then the second input will be a column. Now pulling off the execution pin, we can call into our grid location function that we just created. The grid location is going to ask a few things. Do you want it centered? We don't. We're just going to pass in the row and then the column. Now off the isValid check, we can come into a branch condition. And then we can pull the grid location into a break vector 2D. So we have access to the X and Y. And depending on if the grid location is valid or not, we want to do one of two things. We're going to take our square selection procedural mesh, and we're going to pull off that into the set visibility. And then what we want to do is duplicate that with Control D. So we have two sets of it. If the grid is valid, if it's true, we want to show that selection. So we're going to hit a little check mark under the new visibility to make that procedural mesh visible. If it's false, we want to hide that visibility. So we don't want to show a highlighted grid location, basically. Now, if the true condition, we can pull off that and do a set world location. And the set world location, we basically just need to pass in the square procedural mesh as the target. And then we need to tell it to where to spawn. So we can split the structure pin, we can pass the X and the Y value in, and we need a Z location. We can just borrow the actor's location, so just do get actor location. And then split the structure pin and just pass in the Z value. And this pretty much completes the selection tile function code. So that should pretty much complete the grid blueprint here. So there's not much else we need to do in it. But you'll notice if we go back to our main scene and we play, nothing's really working, right? So we got the code and the functions set up in the grid to be able to utilize. It's kind of up to your discretion on what objects you want to be able to use those functions. So you can do these for NPCs or players, all sorts of things. As an example, we can use the top-down tutorial or template. We can go into the blueprints folder and we can open up the BP _ top-down controller blueprint. So we'll modify this code to make use of our grid, so our player only has the ability to move within the grid confines. It looks like there's three main functions. It has a begin play, it has a mouse and keyboard, and then it has a touch. So we're not going to be doing anything with the touch code, so we can just kind of move this down. The code I set in the mouse and keyboard will need to be replicated into the touch code if you plan to use like a mobile or an iPad or some type of touch device, depending on your prototype. Starting off, what we'll want to do is a call to get actor of class. And then we'll want to get a reference to our grid, so BP _ grid. And then with that, we can right click and promote it to a variable, and we can just call it the grid reference. And the reason we need to do that is because now we have a way to pull values from our grid into this blueprint. Other ways you can do it, of course, you can set up a game manager and then make the reference or the cast from the game manager and then just drive all logic there. So there's a couple different ways to do it. All right, but looking at the keyboard and mouse code, it looks like when the mouse is triggered or clicked, it does this custom function called get location under cursor. You can see that one right here. They also have one for get location under finger. We're not going to be doing that one though. So if you double click, it should open it up here. And there's not much to it. It basically just gets it by a channel, breaks the hit result, and then it passes this location, it looks like, into a cache destination variable. And then it calls a follow code, which works on a navigation mesh. So we can modify this a bit. So let's drag our cursor back, give us a little bit of room. And then I'm going to drag these hit results back over here. Now this get hit result under cursor by channel has a return value. We can actually pull off that into a branch. And then we'll pull into this. If this is false, what we should do is get a reference to our grid and then pull off our grid to get a reference to our square procedural mesh. So get squares procedural mesh. Because remember, we have that ability to hide it. So we can say set visibility, and then we'll just leave it unchecked. And then this will execute under the false condition. And this will just make sure the grid selection is hidden when you drag your mouse over, a location that doesn't have a grid, basically. Or if it's like they click on the sky, or they're basically in a weird spot. Now what we're going to need to do is we're going to need to store this location. So let's create a local variable, and we can call it hit location. And it needs to be a vector. And then we can hold the Alt key, drag it in to get a setter. And then off the location pin, we can just pull this into here and then hook up our true pin like so. And then we're going to hold the Alt key and actually break the vector connection there. Now what we can do is hold Control, drag in our grid reference, and then pull off that, and we're basically going to call the three functions that we just set up in our grid. The first one we can call is the tile location, and then we can pass in our hit location into that input pin for mouse location. So this will pass the where the mouse is to that function, so it can do its calculations. Now we'll want to get another reference to grid, so we'll Control D to duplicate it, pull off that, but this time we'll call the select tile function that we made. And we'll just hook up the execution pins like so. And then we can simply pass the row and the column right into the selection tile, and that'll just tell the function which tile to actually highlight when they're moving the mouse around over it. And then we can duplicate our grid reference one last time, pull off of that, and then we can call the last function we made, which is the grid location. Now for the grid location, we will want to get the center location for it. So we'll want to check the center mark here. And this is going to be so we can tell our player to move to the center of the tile. So we can pass in our row from earlier and our column from earlier. And we can double click to add some reroute nodes here, just to make this a little neater. And then we do have this is valid check, so we can, do one last branch check just to make sure everything's good. And then if it's true, or if it is good, we can hold Alt, drag in our hit location, and then we can pass in the X and Y from the grid location. So we will split this structure pin here, and then we can split this one here. And then we'll just pass in the X. We'll pass in the Y. We don't have the Z value, but that's okay because we can Control click, drag in the hit location, split it. Because we did store it at the beginning, we can pull into that Z reference in case we need it. And then you can just pass in that vector into the location. And then if you wanted to, you can also pass the is valid check into the return node by adding it as an additional output. And then we can just maybe title it valid. And then we'll just pass this through here. So we'll compile and save. And this is just basically just our modified code of the function that they had previously. So now we can go back to the event graph. If we play the game, nothing's going to change because we do have the highlight or the selection working, but the player is not really going to center, but there might be another reason for that. The other part of it is we may want to use that is valid check into an and boolean. So what we can do is maybe drag this back a little bit and then pull into an and boolean. Pass this in here. That way it makes sure one last time that the tile is definitely valid. This will help when you click outside, like if your mouse has the ability to click outside of the grid entirely, that there is no way the player, because the grid won't highlight, their codes in the grid will basically make it so it doesn't highlight or move off it, but the player could still, move to that cache location or make an attempt to anyways. So this will basically stop the movement for that. Now there's another issue here is when you play, you'll notice the mouse doesn't highlight until you click. Well, there's a few issues here. So if you want the behavior to where the tiles highlight in real time, you'll need a tick function. But if we call event tick, the function that holds or controls the highlighting is this get location under cursor, but there's no execution pins. So it's because this function is basically pure, you'd have to uncheck the pure option here. It'll turn it into a blue node, so you can hook up the pins like so. And then now that you have that, you can pull into the get location under cursor. That way it'll actually do the check for you. And then if we compile and save that, now the mouse, no matter where it is, it's actually highlighting the tile. One final issue, you notice if I click a tile, it does go center, even if I click on the corner, but the player doesn't quite make it to the center. If you wanted to address that, you can go to your top-down character, which houses the mesh, and then it has a character movement component. You highlight that, and you have to scroll down and find the nav mesh movement. You'll notice there's a fixed path braking. If you set that to 0, so there is no braking, you should notice that your player or your object will move direct center. Other considerations to make with this prototype is it is navigation based. So as an example, if we come back to our main project here, let's create a new level. So we'll do new level, we'll do a basic. If I come to my content folder and I add a grid and say I reset that location to be center, I'll pop it up 10 units on the Z, and then maybe we'll hit play here. You'll notice that the player can't really move in the grid, even though all the code is there and it's highlighting and it's working. And that's because there's actually it uses the nav mesh here, so you'd have to add a nav mesh bounds volume here. And you can add that here, and it's basically if we show the navigation layer, the player will be able to move everywhere it's green. So we'll want to scale this up to maybe 50 in the X and Y. And then now the player can move everywhere But you'll notice if I click outside the grid, even though there's navigation data, the player is restricted. It can only move within the confines of the grid. And then just like before, I mean, it's a pretty versatile system. We can actually come in and enable your FPS here. And you can notice that if I turn off navigation and hit play, see I'm getting 120 frames almost. If we go to the actual grid component here, so let me just select it. Say we bump the rows and columns, maybe we do 500. You can see it's a pretty large grid. If I hit play, because it's done in the construction script, I'm still getting 120 frames. So you might have a slower load time on the initial launch, but once your game gets going, you know, it's pretty good. So we can do maybe 5,000, and then maybe we do some different colors. And then maybe you don't want to use a 100 size tile. Maybe you want to just do a smaller tile like 50, or maybe you want to do big tiles like 500. And then we can play, and then your grid system's still working exactly as you'd expect it to. Alright everyone, this concludes the grid system tutorial. I hope you found some informative value that you can take into your own projects, but as always, thanks for watching, consider subscribing, and we'll see you on the next one.